Welcome to this explainer. I am absolutely thrilled to have you with me today because we are going to dive straight into something that causes, well, a whole lot of unnecessary stress for students, especially those tackling the Cambridge 0580 mathematics syllabus. We're talking about algebra. Now, I see it all the time. A lot of people look at algebraic equations on an exam paper and they completely freeze. They think they're staring at some sort of dark magic or a secret code that only geniuses can read. But I want to completely shift your perspective today. Listen, algebra isn't magic. It's actually just a highly reliable, perfectly logical set of tools. I want you to think of it as a mechanical toolkit, and today we are going to crack open that box, pull out every single tool, and unpack exactly how to use them to confidently build and dismantle literally any mathematical problem you face.
Okay, so here's our roadmap for today. This is the ultimate strategy to mastering the 5 essential tools in our mathematical toolkit. First up, we're going to look at expanding algebraic brackets. Second, we will master the art of factorizing. Third, we'll be cracking quadratic expressions. After that, we'll learn the secrets of rearranging complex formulae. And finally, we are going to face the ultimate challenge, the final boss, taming algebraic fractions. Let's get right to it.
Let's start with the very first tool in our kit, expanding algebraic brackets. I honestly like to think of expanding brackets as simply taking everything out of a neatly packed box. You see, when expressions are grouped inside brackets, they're packed away for storage. Expanding is just the mechanical process of taking those items out of the box so we can actually get to work with them.
Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so the core rule here is perfectly simple. When you're removing brackets, every single term inside that bracket absolutely must be multiplied by whatever is sitting right outside of it. Take a look at our first example here. We've got a 3 sitting right next to a bracket containing x plus 4. So we multiply the 3 by the x, which gets us 3x. Then we multiply that same 3 by the 4, which gives us 12. Combine them, and you get 3x plus 12. Super easy, right? But here is exactly where you have to be careful. Watch your signs. This is where examiners catch people out. In the second example, we have a negative 4p outside the bracket. When we multiply that minus 4p by a minus q inside, remember that 2 negatives make a positive. That gives us a positive 4pq at the end. So the absolutely crucial takeaway here is always carry the sign with your multiplier.
Now, let's see how this exact same logic builds when we introduce pairs of brackets. When you have 2 brackets multiplying each other, don't panic. It's literally just an extension of the exact same rule. You simply multiply every term in the first bracket by every single term in the second bracket. Let's walk through it. For x plus 3 times x plus 5, we multiply x by x to get x squared, then x by 5 to get 5x. Next, we move to the 3. 3 by x gets us 3x, and 3 by 5 gets us 15. We lay the whole sequence out, x squared plus 5x plus 3x plus 15. Then we just do a little tidying up. Combine the like terms right in the middle, the 5x and the 3x, to reach our final super clean result of x squared plus 8x plus 15. It is simple, it's systematic, and if you follow the steps, it's completely foolproof.
All right, that brings us neatly to our second tool, the art of factorizing. If expanding is unpacking the box, then factorizing is simply packing it all back up. It's the exact reverse process of what we just did. We're essentially going on a hunt for common elements that we can pull out to tidy up our expression.
We can really easily see the relationship between the two when we look at them side by side. Look at the expanded form, 10x plus 15. Ask yourself, what is the largest number that divides evenly into both 10 and 15? Well, it's 5, right? So we pull that 5 outside of our new bracket. 10x divided by 5 leaves a 2x inside. 15 divided by 5 leaves a 3 inside. And just like that, we've neatly packed it back up into 5 times the bracket 2x plus 3. Now this is important. They represent the exact same mathematical value. We haven't changed what it's worth. We've just changed the representation to make it more useful for whatever the exam question is asking us to do. Before we move on from factorizing, I absolutely have to share my favorite tool in the entire box. Spotting the difference of 2 squares is honestly like having a cheat code for your algebra exams. If you see 2 perfect squares subtracted from one another, like x squared minus y squared, you literally do not need to do any complex math. None. It will always instantly factorize into x plus y times x minus y, every single time. So if you had an expression like x squared minus 25, well, 25 is just 5 squared, right? So boom,
Your answer is x plus 5 times x minus 5. Please do yourself a favor and memorize this pattern.
Excellent. We are making fantastic time. Let's tackle tool number 3, cracking quadratic expressions. Quadratics, which are expressions where the highest power is a squared term, often look incredibly intimidating to students. But I promise you, they are essentially just logic puzzles waiting to be solved.
Let's look at a classic exam example right here. X squared plus 5x plus 6. To pack this back into two neat brackets, we just follow a simple logical sequence. Step 1, we know the absolute only way to get an x squared is x times x, so an x goes right at the front of each bracket. Step 2, look at the final number, the constant. In this case, it's a positive 6. We need two numbers that multiply together to make 6. But, and here's the catch, step 3 is the key to the whole puzzle. Those exact same two numbers must also add together to make the middle number, which is a positive 5. So what multiplies to 6 and adds to 5? Positive 3 and positive 2. Step 4, just drop them straight into the brackets. Our final result is x plus 3 times x plus 2. See, you've just cracked a quadratic.
But I can already hear you asking, what happens when things get a little spicy? What if there's a number, a coefficient, sitting right in front of that squared term, like 2x squared plus 11x plus 12? Does our whole logical system just break down?
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, getting back to our spicy quadratic. Does the system break down? Not at all. The logic remains exactly the same. We just have to make one tiny adjustment. To get 2x squared at the start, our brackets must start with 2x and x. Easy enough. We still look for the factors of our constant, which is 12. But this time, because one of those factors is going to be multiplied by the 2x, we have to check our sums with that cross multiplication in mind. So, through a little bit of trial and error with the factors of 12, we find that a 3 and a 4 work perfectly. Why? Because 2x times 4 is 8x, plus 3 times x is 3x, and 8x plus 3x adds up beautifully to our middle term of 11x, giving us our perfect solution, 2x plus 3 times x plus 4.
Let's keep this momentum going. You're doing great. Tool number 4 is rearranging complex formula. This is really all about shifting your perspective. Sometimes an equation is perfectly correct, but it's shining the spotlight on the completely wrong variable for what you need to solve. Rearranging simply allows us to grab that spotlight and shift it to whatever letter we need to be the star of the show. Let's visualize this together. In our original formula up here, a equals 2b plus c. Here, a is what we call the subject. It's sitting all by itself on one side of the equal sign. But what if the exam asks us to calculate b? We need to use inverse operations to strip away everything surrounding that b, peeling it back layer by layer, exactly like an onion. First, we remove the positive c by doing the opposite, subtracting c from both sides. That gets us a minus c equals 2b. Then we need to undo that multiplication, so we divide everything by 2. The result? A minus c all divided by 2 equals b. We've successfully shifted the spotlight. Let's look at how this precise tool unlocks real-world math problems. Here is the standard formula for the volume of a cylinder. V equals pi times r squared times h. What if you're given the volume and the height and you need to find the radius? We have to make r the subject. Step 1. Divide both sides by pi and h. This leaves r squared sitting entirely isolated on the right. Step 2. How do we undo a square? We take the square root of both sides. Step 3 yields our final result. R equals the square root of v divided by pi h. Note that little plus or minus sign there. Mathematically, a square root always has a positive and negative answer, though obviously in physical geometry, a radius is always going to be positive. So, let's quickly summarize these tricky rearrangements. Always work backwards using inverse operations. Address your addition and subtraction first, then move on to your multiplication and division. If your target letter is squared, your final move is always going to be a square root. But listen up, pay special attention to this last point on the slide. It's an absolute lifesaver. If the letter you want to isolate appears twice in the equation, like ax plus bx equals c, just use the factorizing tool we learned a few minutes ago. Pull the x out into x times the bracket a plus b. Then simply divide by the bracket. It's genuinely amazing how all these tools work together, right?
All right, take a breath. We have arrived at the final section. Tool number 5, taming algebraic fractions. I like to call this the final boss of algebra because, honestly, it looks terrifying on the page. But I am here to completely reassure you, letters and fractions follow the exact same rules as numbers and fractions. Period. There's no new magic here.
Comparing arithmetic directly to algebra on this slide brilliantly illustrates my point. Look at the numeric fraction side on the left, 1/4 plus 1/3. How do we add them? You already know this. We find a common denominator by multiplying 4 and 3 to get 12. Then we cross-multiply the numerators to get 3 plus 4, giving us a neat 7/12. Now shift your eyes to the algebra side, 1/a plus 1/b. The process is literally identical. Multiply the denominators a and b to get a common denominator of ab. Cross-multiply to get b plus a on top. The result is just b plus a over ab. There are absolutely no new rules here. It's just a different coat of paint. But let's push this strategy to the limit. What happens when those algebraic denominators are complex expressions and they clearly aren't multiples of each other? Imagine the exam gives you 2 over the bracket x plus 1 and asks you to add it to 1 over the bracket x plus 2. How on earth do we find a common denominator for something like that?
The secret is surprisingly straightforward. Just like when we had denominators of 4 and 3, and we simply multiply them together to get 12, we do the exact same thing here. We find the lowest common multiple by literally multiplying the two brackets together. Our new shared base is just x plus 1 times x plus 2. You don't even need to expand the bottom, just stick them next to each other in brackets. Let's walk this final boss right across the finish line. Step 1. Because we multiplied the denominators together, we have to cross-multiply the numerators. The 2 gets multiplied by x plus 2, and the 1 gets multiplied by x plus 1. Step 2, we write it all out as one massive fraction over our shared denominator. Step 3, we grab our very first tool, expanding brackets, and use it on the top line. 2 times x is 2x, 2 times 2 is 4, giving us 2x plus 4, and 1 times x plus 1 is just x plus 1. Step 4, we combine the like terms on top. 2x plus x is 3x, and 4 plus 1 is 5, giving us a final, highly satisfying full marks answer of 3x plus 5 all over our common denominator of x plus 1 times x plus 2. Look at that. We've condensed a chaotic, messy problem into a neat, perfectly solved package.
Just look at what we've accomplished today. We've gone from unpacking simple brackets to entirely taming complex algebraic fractions. So the absolute crucial takeaway is this. Algebra is not a mystery to be feared. It's a mechanical system, and you are the master mechanic. Now that you have the toolkit, expanding, factorizing, quadratics, rearranging, and fraction rules, will you let a page of letters intimidate you? Or will you pull out these tools, apply the rules systematically, and confidently dismantle any exam equation you face? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainers. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here.